Hi, my name is Martin King. I'm one of the senior fluid systems designers here at Legacy Chillers. Today we're fielding a question from Bob in Delaware. He had some questions regarding fan cycle control in a process chiller. Well, we're going to be answering that question now. We're going to be covering on-off control as well as variable fan speed control or VFD drive control. They both have their advantages. Again, like all of these videos that we produce, at the very end there'll be some opportunities for you to submit your questions to us, because these videos are all about you guys. We're trying to get our answers out there so you further understand process chillers. Thanks again for stopping in and enjoy the video.
So this SmartDrop video is going to be covering the use of a variable frequency drive to control a condenser fan motor. This has become a very popular option at Legacy Chillers. So before we get into the specifics of that, let's do a quick review of a basic low voltage control component diagram. This is the same diagram that we use on all of our chillers. We just simply add or delete inputs and outputs based on the particular options the customer has purchased. So the first thing here is our HMI touchscreen. This is standard on all of our models. It's ultra bright. It has a built-in web server, has a ton of features. This is our PLC. This is the brains of the outfit, and you'll notice the PLC itself has different inputs and outputs on it. The first logic card we come to here is our Thermistor Card. So this particular card is on every single chiller, and it measures temperature. It reads data from our thermistors. The next one here is our Transducer Card. So this card's dedicated to measuring pressure. We use this primarily for refrigeration pressure, but we also use it to measure water pressure in the case we have VFD controlled pumps and such. So on this particular chiller, it only has one refrigeration circuit, so we're only really sensing discharge and suction pressure. And then we have two output cards. This is an 8 output card. This is an 18 output card. You'll notice there's a ton of open spots because we have pre-assigned options. So again, on this particular chiller, very limited options on it. So we've only included the outputs that are needed. And then the last card here, this is a analog output card, 0 to 10 volt DC, and its job is to output voltage to our VFD for our condenser fan motor, right? So this is the one we're going to be talking about in a second here. So let's roll back up on top here and let's look up the logic of controlling a fan. So what we do here is on our touchscreen, the customer will set what their desired pressure is for their refrigeration system when the compressor is running. So let's just say, for an example, the customer wants to maintain 225 psi refrigeration pressure when the compressor is running. So what we're going to do is we set it here, and then when the compressor comes on, the PLC is looking at the discharge pressure on this transducer. And let's say, for example, the set point, the customer wants to maintain 225 psi, but the actual pressure is, let's say, 250 psi. All right, so that's a little bit higher than it needs to be. So through the magic of what they call a PID loop, it's a special program that's running on the PLC. The PLC says, wait a minute, my head pressure is a little bit too high, right? So what we're going to do is we're going to go ahead and increase the output on this analog card to the VFD, and what happens is that'll cause the fan motor to speed up, moving more airflow, which will drop the head pressure, right? So, and that's basically it. So in other words, if your head pressure is too low, so in other words, if your set point is 225 psi and the actual pressure is 200 psi, what's going to happen is the PLC through the PID loop will drop the voltage to the fan motor, which will slow it down, less airflow, and causing the head pressure to run up. Now, the key benefit to this over, say, an on-off fan cycle control, or in some cases no fan cycle at all, this allows the user to maintain a very, very tight pressure range on their discharge, which causes a lot of stability on the refrigeration system. So that's basically what that's all about. In some cases, in some climates, just by use of a variable frequency drive for the condenser fan motor, we can circumvent the use of more expensive low ambient options, such as flooded condenser, which makes the net price to the customer quite a bit more competitive. So anyway, that's pretty much it for this SmartDrop item. This is how a variable fan speed control operates using a VFD drive, and I hope this information has been helpful to you. All right, well, that's your SmartDrop educational video for today. Thanks again for stopping in and hanging out with us for a little bit. If you have any questions that we can answer for you, please don't forget to submit to our LinkedIn, Facebook, or Twitter feeds. You can also go to our website and submit questions to us there. We're looking forward to working with you. And if you happen to have any process chiller needs, we're here to guide you through the process to a successful project. Thanks again. My name is Martin King. I'm with Legacy Chillers, and I'm happy to meet you.